All right. Hello, everyone. We're excited to have you here for this Docker AI Machine Learning Hackathon webinar. And I'm excited to have Patrick McFadden joining us. We're super excited to learn from him. He's joining us from DataStax. Let him introduce himself here in just a moment. But before doing so, for any of you that are joining us, if you haven't joined our AI Machine Learning Hackathon, we'll drop a link in the chat in just a minute. But we've partnered with DevPost and we'll be running the hackathon for the next several weeks as well. And over the next several weeks, we'll be running several of these workshops, several of these webinars that you can learn about this space. So if you're brand new to the AI machine learning space, no worries. Um, we've got you covered, and we'll be more than happy to help you out. While we're going through this as well, if you've got questions, feel free to drop them into chat as well, and we'll either respond to them as we go along or hold them to the end, just depending on the question as well too. And this webinar will be recorded. It will be shared on YouTube, and we'll also put all the links and everything in the resources with the hackathon as well. And so with that, I'll pass the baton off to Patrick and let him introduce himself and just let him jump right in. And so Patrick, again, welcome. Glad to have you here.
Thank you, Michael.
The mic is now yours.
All right, let's go. So I hope you like my title. Petabyte scale vector store. Why in the world would you need that? Well, I hope at the end you'll see why. But this is also a journey. We're all kind of in this journey right now of generative AI is definitely causing a bit of a ripple in our poor tech industry. I guess I should tsunami. And so I just want to make sure that everyone knows that we're all learning together. So let's not get too freaked out. But let me quickly introduce myself. Like I like I said, my name is Patrick, and so just a little bit about where my background is. I'm an Apache Cassandra committer. I've been working on the project for about 12 years now. If you don't know about Cassandra, you will by the end of this. And also a Cal Poly engineer. If there's any Mustangs out there, go Mustangs. Also, just wrote a book. It was published earlier this year in January with my friend Jeff Carpenter, managing cloud native data on Kubernetes. And a good portion of that is running AI and ML workloads inside Kubernetes. So if you're running a containerized workload inside Kubernetes and you happen to be thinking about doing like your AI workloads in there, I would recommend going and reading that book. It's a really cool book. Of course, it's on O'Reilly Learning if you're a part of that, and at booksellers everywhere, quality bookstores everywhere. But more than likely, you're just going to go to Amazon or O'Reilly Learning and get the PDF. But there, it is relevant to today's environment because it's not just running a database; it's also all the pipeline. So that's my background. And part of my work with Cassandra has been around generative AI. So let's dig in here. So this is where we are. And you're probably writing a chatbot if you're doing anything with Gen AI, right? But is Gen AI a chatbot? ChatGPT jumped onto the scene last year, almost a year ago now, it's 11 months ago, and blew everyone's mind because you're like, wow, man, this is the future. And of course, everyone freaked out because they're like, this is it. This is the robot overlords we were all waiting for. But I think we've gotten over that part, but we're also looking at what LLMs and generative AI are, how they're going to affect the way we interact with applications. It definitely has caused enough conversations, and probably a lot of conversations if you're a developer or work in infrastructure and technology. If you haven't had a meeting with the word AI in it, then what do you do? What are you doing? um, but I don't think that's not really the future of Gen AI. Chatbots are a good POC for us all to do. Chat with my data type thing, get a PDF or something like that. But Andre Karpathy was recently at a hackathon and there's a really cool, I put the link in here with the QR code so you can check it out. It was a really cool little talk that he did, he did like an opening statement to a hackathon. They just said, hey, can you say a few words? And he did, and the few words that he said were, agents, yo, that's where it's going. And he, this is not just him, but he said it very eloquently. It's not just, AGI. The future where AGI will be is not going to be this like uber brain, right? I'm sorry, science fiction got it wrong probably. It's going to be this thing of multiple agents and where they are, and what agents mean for the rest of us is it's a distributed systems problem. These are these large scale agent networks that work together. They have these three properties. It's loosely connected, so they come and they go, and that dynamic part of that is part of the agent experience. If you've done any work with agents so far, you'll know that they spawn and they do some work and then they get deleted, and that life cycle is very dynamic. And because it's dynamic, it's growing and shrinking. There's this requirement for shared context. You don't want to have agents starting up and starting from scratch every single time. That is probably the most brute force way to run agent networks, and that's not the way we want to do it. We want to have context, and that requirement is really big. And it's because what we get out of that is, on the left, this is probably your typical experience with Siri, and nobody wants this experience. Sorry if I just made everyone's phone start talking when I said that. But that was not AI. That was a chat interface, a very rudimentary chat interface with voice. And there was no intelligence in it. But what we all secretly wanted was what the Jarvis thing was. And you're like, thanks, Iron Man, for making us all jelly. Because that, if you think of the experience there, was like, hey, go do this. And hey, in the background, I did this and that. And I'm actually making you, Tony Stark, better because I'm augmenting what you're doing. And that is really cool future. Jarvis is definitely way ahead of where anything is today, but something close. A little bit close, and I think we're getting there. If you've played with ChatGPT and done any of the like prompt work, you can get a similar experience, getting closer every day. But it's when we're building applications, thinking about how Gen AI fits into the background. It won't be in the foreground, it'll be in the background. That's that Jarvis experience. And vector databases have a lot to do with that right now. And they are now having their time in the sun. Vector as a concept has been around for a very long time. It's not a new concept, but LLMs have made vector databases super relevant. And the reason is, we're gonna have some real talk here. And by the way, thanks to Midjourney for providing me with this image. I said, show me a hallucination, basically, and this is what it came up with. And I'm like, that is perfect. A pink elephant, sure. Or like a bender, a night of drinking, I don't know. But anyway, hallucinations, there it is. But LLMs, as we now have a much larger experience with them, as in people who didn't study LLMs for a long time, because LLMs have been around for a while, but it's just now it's been dumped into the mass. And so we've all probably had experience with LLMs, probably through ChatGPT, but we're learning a lot about them. Namely, they're really great at communication, and it's this natural language interface where you can tell it. You can even be sketchy about what you're going to say, and it figures it out. That is awesome, because that's how humans communicate. We're very brief with each other. You don't have to be precise and to have a lack of precision but getting your point across is really a human experience, and LMs are great at that. They're also surprisingly good at reasoning, like picking out steps. Like, I want to do this thing, show me step by step. That is a feature of LLMs that have worked. And like I said, it's a surprise. That was not the point. And now we're seeing how they're really good at that and starting to exploit that. The thing that they're really terrible at is knowledge, or the information. LLMs are not databases. And we did get lured into that, as several people did, of using Google as a replacement, or LLMs as a replacement for Google. Like, I'll just ask ChatGPT, and then they found out the meaning of the word hallucination, because LLMs do have knowledge in them. They're used to create them, but they're time boxed. They have a certain amount of information, and they're just terrible about being able to reproduce that information. So that I think that's this is just the reality we have, and it's also where research is at. If you look at the current state of the art, it's LLMs are becoming much more specialized and focused, and not trying to pack in like the entire world's knowledge. It isn't like Wikipedia in an LLM. That's not the point. But what that means is now we were into this realm of context, and this is a good example of the type of context that we need badly. So here's a statement that I would love to tell Siri: like, find out if my kids are going to be home for dinner, and if not, order DoorDash from that Indian place. Otherwise, just order a couple of our normal pizzas. That, if you and I were friends and I said that to you, I would assume that we have context, right? Because there's a lot of impliedness in all of this. And man, wouldn't that be awesome if Siri could do that? Because this is an agent experience, right? This is agents can do different things, but the context is like, all right, who are my kids? I don't know, that Indian place. What does that mean? Well, it's the one we always order from that has really awesome food. Okay, but that's a shared context. And how would I understand that? Well, maybe there was a history. Like, I always order from the same place, and it's great. So when DoorDash does an order, I'm not just getting random food. And then our normal pizzas. Well, what does that mean? Again, context, history. There's knowledge that got stored at some point. And it's not just a database lookup, although it is. But I remember this is like one of the things about AI that everyone is concerned about for years and years. And this is what put us into this AI winter and made us do inference only, is because things like this contextual conversation is hard. And even ChatGPT can only remember around 10,000 words. So you need a much larger context. If privacy issues aside, I would love to have something local, like only running on my phone, that really understood who I was, that I could handle the security, or that it was an environment that I could control. It's my data. It's not just getting dumped into some random pool of information. So, all these new concerns are similar to the concerns we have now. If I do banking, I don't want to blend with other people's banking needs. I want my own environment. And banks do a really good job of partitioning that data. So we're just kind of solving the same problem again, but with context. And AI agents in the infrastructure of building autonomous agents is this chunk of code that has access to a LLM as well as a vector database for context. So if you think of the flow of information, LLMs provide, that interface for language and for reasoning, but the vector database is the interface into actual knowledge and the truthiness of what you're trying to say. And this is the name of the game, is accuracy. And AI agents that are operating, say, booking your vacation or ordering your pizza or going to DoorDash and ordering that awesome Indian food that you wanted. The AI agent can have access to all these things and in combination make things really work. And if you haven't heard this, RAG, retrieval augmented generation, this will probably be the word of the year for the next year. I've been to a lot of AI conferences in the past couple of months, and this is all we're talking about. And in a nutshell, it's a pattern, but it's also, it can be codified. There are projects like LangChain and Llama Index that do this, that do retrieval augmented generation. And the idea is that, and the pattern is that when someone asks a question, and there's, a user asks a question, that the pattern is that it will take the person who built the agent or the chatbot will use a large language model, but also augment it with these prompts, their own prompts, but then data from a vector database. So when I ask it a question about something about me, like, hey, what's the delivery time for the pizzas that I like? It can say, first of all, determine that I'm asking for something like delivery times, but then it has to go to the data source and do something about like, where was this guy usually order for pizza? Where? And so pulling those together, running that entire package through an LLM will allow the LLM to respond with truth, but also very clean English, where that thing, the LLM could respond with, oh, just checking at your favorite Mary's Pizza site. It's looks like the delivery times today are around 45 minutes. And so, okay, great. But there's so much magic that goes into something so simple like that. And RAG is a pattern right now that you can see. And I put if you want to read the paper, cite your sources. I have the QR code there. You can check that out. Looking forward, and no pun intended, forward active retrieval generation is another method to reduce the amount of hallucination while increasing the amount of knowledge that is given back to the user. What this is, that it takes this concept of taking the question from the user, and then there's a reasoning engine in the LLM that actually is like extracting more questions and saying, oh, okay, maybe there's more to this. Like if you ask like a question about a public figure, like a president or, a sports figure or something like that, it'll say, wait a minute, before I respond, maybe I can go ask some different questions, like the sports figure, like, oh, where did they get their start? What is their current team that they're on? It will come up with new questions. Go query the vector engine for something similar to that, or even a regular database in this case, like here, go do a lookup, and then summarize that all back before returning back to the user. And again, this chain of thought type pattern is about getting better, accurate, and more interesting, relevant results. And it requires a lot of vector search to make that happen. And you can only imagine, and there's a punchline to this, you can only imagine how much data is going to be required, because, as we look at things like this, where we're even doing, this is a really cool pattern that's happening. Now, I don't know if you've ever used the code generation or the code interpreter that's running on ChatGPT, but one of the things that it'll do is if you hand it a CSV file and say, oh, can you write me a graph for this column? It'll write Python code. But what's really, really cool, if it makes a mistake, it throws an exception or something, it will see it and query its own LLM, like, how do I fix this? And then fix the Python code and then rerun it, which is a little creepy to watch sometimes, but it's still cool, right? Because it actually delivers the response, but it's doing this thing where it's like, all right, here's my answer, better check it. And then, ooh, that's the wrong answer, but it has to have the knowledge base to check it from. So this chain of thought, like, here's my thoughts on this, and here's the knowledge base. Well, once before it answers, well, can you check your answer before you give it back to me? Because right now, ChatGPT as a just baseline will just statistically give you the answer that it thinks looks good, not that it's actually correct. And again, getting to the punchline of like, this is the day for vector to be in the sun. Well, it's only going to get worse, because models are becoming absolutely multimodal, big time. And again, back to ChatGPT, they just released the thing where you can upload a picture, or then now you can interact it with voice. Those are all different modes of data. Text has been the mainstay of, like, NLP, natural language processing, has been such a mainstay with LLMs, but now we're branching out, and that is getting closer to how humans interact. I want to be able to, verbally chat with something, or I want to show a picture of something, or like, hey, the example that ChatGPT used, they showed a picture of a bike, and they're like, how do I lower the seat on this thing? That's pretty cool. I mean, that's something my kid would text me, like, here's a picture of my bike. How do I fix this? As humans, we were like, oh, okay. It's a lot easier than if he just sent me a text message and say, how do I fix my seat on my bike? I'm like, what is it? Oh, let me see a picture of your bike. That's how humans work. Well, now that's where models are going, becoming highly multimodal, and to the point where it's not even just like, just images and text. It's audio, infrared, different types of data that can be synthesized and transformed and used in this massive it's going beyond what humans can do, and it gives us, this will be some open doors for some superpowers, right? Whenever I have it in my suit that I'm wearing, my metal suit, and I'm fighting bad guys, Iron Man, but thinking of like all the different modes of data that it will help answer questions better or give us more truth. And that a lot of data. So this is, I love this graph. It always shows up every time someone talks about, oh, the explosion of data. I mean, we're gonna have 175 zettabytes by 2025. All right. I'm still not at a zettabyte currently in my house, but I think I'm approaching that. But what's going to drive that? And I don't even think this graph is even relevant anymore. It's probably more than that. Is the amount of data that we're going to collect and vectorize, including vector embeddings, that will be in support of all of the things we're doing. And it's gonna explode. Those of you who've been involved in any kind of data infrastructure, some things only store a little bit, but as soon as you get machines involved in this, then the data volumes just explode. It's a crazy time, right? By the way, that's the whole business model behind Splunk, right? It's like, no, no, no. Give us all your log data and all your money. And that was because you wanted to have enough data to answer the question, but that data wasn't generated by humans. It was all log data. It was machine generated. Machines generating data, they just don't care, man. And modal data like that, images and things like that are going to get dumped into places where they can service more. Like when we have these AI agents doing work, they're going to have this access to this massive set of data. And a lifetime's worth of data for a human is going to be a lot. And there have been specialty vector databases that have been around or emerging as vector is becoming more of a problem to solve with LLM and Gen AI. But they're built around a very specialty use case, which was they're first of all they're new. They're built around an index, but at this point, vector search is completely ubiquitous. Every database probably that you've ever used probably supports it, and I laughingly say, except for Informix. Informix will never change, but it's just everywhere, and it's just an undifferentiated feature. So at this point, we're making it's now thinking about the data needs that you have with vector search as a feature. And of course, I mentioned the fact that I work on Cassandra, so let's talk about that a little bit. That's what we did. We understand that data is a complete picture, but vector is going to be yet another use case that we all have to support. And being a Cassandra committer, I never want to do anything that doesn't scale. And so if you don't know anything about Cassandra, we've spent 14 years on this project. I've been there for a good portion of that. And was built inside large hyperscalers and for solving our own problems. And those problems are that massive amounts of data, but more importantly, having massive amounts of data and reliable massive amounts of data. This is a database that will not lose data, and it will run in a variety of environments and around the world, active. Cassandra posted this slide at ApacheCon last year, and everybody loves their slides. But there's bigger clusters out there. Huawei is an example of one that has a much bigger footprint with Cassandra. And of course, you use it every day at Netflix, Bloomberg, Walmart, you name it, it's out there. And it's just because, and it's quietly being this database of record for companies that need scale. So that's why we were like, hey, you know what? We want to support Gen AI because that's a great use case. You don't want to lose data. You need scale and you need global distribution. And when people talk about AI and agents, there's a requirement for this invincible brain and that knowledge base that never goes away. So that shared nothing, the linear scale, that big replication, because the way Cassandra works, where it can be active across multiple data centers around the world, it's going to hit this use case. And I think this is going to be what we're going to see for the next years to come, is these, like I said, with agent networks, it's going to be very disconnected, dynamic, but global. when Netflix has a great feature whenever you put something in your in your playlist, and you do that in America, and like I do it in San Francisco, and then I fly to London, it's still there. That's great. And I change my playlist in London, and I fly back to San Francisco. It's still there. Just no one says that's a groundbreaking feature, but it takes a lot of work to make that work. And that's one of the reasons I use Cassandra, is because it just does that, and it takes away the hard parts of data in that regard. And agents will need access to the exact same thing, where it's just not, you don't have to worry about the data. The data's there, it will be there, it's fine. And scale, there's no problem there. So you can get to building what you need to build. So one of the things we're doing in the project is thinking hard about solving problems around vector search and making sure that they adhere to what's happening with the industry. Gen AI has once again changed what's important around data, and it's great. I always love a challenge, but the 5 problems that we're trying to solve as we're looking at these, our contribution. Is first of all to scale out, and scale out is hard, and we've been doing it for a long time, and we've really stuck to our guns when it comes to scale out as just a first class in Cassandra. Just no upper limits. Like, of course there are upper limits. The upper limits in this case would be planet Earth that we found so far. So we want to make sure that we're ready for the next phase, which will be the solar system, and then whatever's after that. But you should not have to worry about like hitting your head against the top. And that's a newer problem, but if you've ever worked with any kind of index, this garbage collection, like pruning obsolete indexes is a tough problem for LLMs, because once it goes into LLM, it's kind of there for life. So putting it in vectors is also a thing, but making sure that whenever things change, like I've changed my favorite pizza place. I don't want to keep going to Mary's. I want to go to Mambo's. By the way, those are really great places to get pizza if you're ever in the North Bay. But I want to prune out that old information so I don't get this hallucination again. And then effective use of disk. Indexes tend to blow up, and we don't want that, but it's also a way to limit the amount of throughput you can have. We want to solve that. And composability, the hybrid search problem. I don't want to just do a vector similarity search and say, hey, where's my data based on a search? I want to do it also with some predicates. Like I want to limit it to just one thing or another. And that's how you scale your queries. And we always want to have our queries running in the single digit milliseconds or less. And sometimes to do that, you have to limit the amount of data you're looking at. And there's tricks that we have to do that, but giving a developer the option to say, I just want to look at this little tiny subset, we should do that. And then finally, concurrency, which has been something we noticed is a bigger problem for any vector indexing system, because vector indexing was originally built on the idea of batch. And so you take a Spark job, you dump a bunch of data into like something like Parquet or a file system, and then you have an indexer like the Facebook indexing face, would index all of it, prepare it, and then it would be a read-only, pretty much a read-only data set. So it would be write once, read many. And that concurrency is a completely different use case where it's an application and things change all the time. Well, one of the things we found is that that is a big problem for existing databases or vector stores that are out there. And we did this measurement against Pinecone, and Pinecone is one of those things that's based on read or do your writes once and then read many. But one of the things that on concurrency that you see is if you're doing a bunch of reads and then you start writing to Pinecone immediately, it will just drop the performance to the ground. And the reason is because the indexer fires up and it just pauses everything. And you won't get relevant results for a while. Based on what it was originally for, that makes sense. But that's not something we're okay with. We want the performance to be like, and we already had built this around 8 years ago into Cassandra, so you should never see a performance hit on indexing. As a matter of fact, we think indexing should be immediate. So as soon as you put data into the system, it's already indexed. So we blow out this concurrency. And I should stop here real quick. The thing that makes this work, which is really cool, I'll put this as a side, we built our own indexing engine. We originally had done, and I don't think I have a slide on this, but we had originally worked with HNSW on Lucene. Lucene did not cover the basis for us. Again, same problem. It's a document indexing system. You know, it's meant to index documents of text. Same problem. It was having concurrency issues. So we have a new library called JVector. It's kind of taken off in the Java community, but it's built for this problem, and it's multi-core, multi-thread. It just scales like crazy, but it's really built on concurrent, fast indexing with highly relevant results. So what we did in Cassandra was, and this is also interesting, is how we did it. And what we did was we just added a new type to the data model. So there's a new type called vector. It takes a float. That's the only type that we support because all vector dimension or all the vector embeddings are float 32s. So that's what we support for right now. And then it takes the number of dimensions that you're going to put in the embedding. Now I put 5, but it's typical to see a whole lot more. If you use Ada, for instance, Ada does 1536 dimensions. So you need to account for that. But the whole idea why we did it this way is because it's specializing a specific type in the database for this reason, which is now whenever you index your data on, when you index a vector field, it will go through our storage attached index engine, but it also uses JVector. So it's just kind of puts it off to the side in a different kind of indexing scheme. But it's doing an ANN index, which is approximate nearest neighbor indexing. And then what you can then do is add it to your queries. So you can add predicates, it's just another select query, but it does this ANN of, it's an approximate nearest neighbor of. Now, if you're not familiar with approximate nearest neighbor, just real quick on that, that is, then that's a good one to mention too, because there are really two NNs. There's the KNN and the ANN. KNN, K nearest neighbor, is an exact match. So what it does is it takes a vector, I'll give you an example. Let's say that you have a picture and you want to see all the other pictures that are close to it. Well, that takes, first of all, taking a batch of pictures and indexing those. Like you would run it through a model, create the vector, and then store the vector in a vector database. And so, for instance, we have this item vector that stores that. But then whenever you wanted to compare a picture, you would take a picture, the application would vectorize that image and then use this ANN of search to find similar images. Now, similar meaning that approximation. Now, ANN gives you, it's an approximation algorithm, so it's faster. Every vector store uses ANN. And what does that mean? It could be that it misses, it is not 100% correct because it has to do approximations. KNN is like a Spark job. It will look at every single piece of data, find the similarity, and rank it exactly. And KNN is for exactness, but it is a much more intensive job. And what's found is that ANN is pretty good. It's the relevancy is above 90%. If you know, it keeps in the 90 to 100%. It's pretty close, but it's just really, really fast. And so, but what an ANN search does, you know, like I put a limit on here of 1. What you're asking for is give me things that are close, and you can even ask how close is it. And if you do 5, it'll give you the 5 closest. And with an image, that kind of makes sense. Like if you take a picture of a house and you say, give me things that are close to it, then you're going to get similar looking houses, or maybe even just houses. And that's more or less what you want. You're not looking for this exact house. Now you may find it, but that's not the point of the search. Thinking in terms of like text is more about like you can use an embedding model that does some things like sentiment. So here's a thing that talks glowingly about, some topic, right? And you want things that are similar to that topic inside your text, like the search. And It's very, very different from a text search where you're looking for a particular word. Like I only want to hear about cats, so I'm just going to do a text search for the word cat. But what if I want to learn about, how cats are great companions? Okay, well, that's a sentiment, and you might get a response back about how lizards are great companions too, because that's similar, or how cats are not great companions, because that's similar. Um, it's that type of thing where it's now you're being a little fuzzier with your search. So I kind of took a tangent there, but I think it's worth mentioning. Um, so one of the things we've done at DataStax too is started thinking more about how we work with infrastructure, the database along, and then finally the actual application. Like, what's the layer between? And the layer is between, and it's becoming this ecosystem of libraries that abstract, and it's not a direct access thing. So we have a library we call Casio. It works with LangChain. There shouldn't be a dotted line behind Llama Index. Llama Index, if you're not familiar with these are pretty popular libraries for interacting with data, LLMs, and vector databases. Sounds like a good fit, right? Um, and if you've ever done it, like, you can go do it. And I actually have some workbooks that you can walk through to do these things. Um, but we've gotten to the point now where if you use Casio and LangChain, you don't even have to really understand the data model anymore. It will write its own data model as a memory. And that's fascinating. Wow. We've gotten to the point where you don't really have to interact with the database. We just have to have one that can support what we need to do. That's what this library does. Um, and I think that at this point, the most important thing right now is your app. And we're at DataStax, we're very interested in what you're building and making sure that we're supporting that. And with Cassandra, with our system called Astra, and so Astra is a Cassandra as a service, and we probably run a lot more Cassandra than anyone. We have thousands and thousands of Cassandra clusters we work with all the time, but with Astra, it's not about just running it; it's about making it easy for developers too. So, um, the, just to let you know, this is all in open source, by the way. So the open source project, we upstream all our changes, and so Astra is usually just a little ahead of what's in the open source because we were in the middle of donating it or something like that, but it is reflected in the open source Cassandra. So it's not just like some weird fork that goes off and does its own thing. Nope, it's right along the line with that. And if you want to use open source Cassandra, that's great. We love, but really for Astra, we want to make it easy. And so the scale, just it's serverless. It scales to 0 if you need to. And you don't have to think about like, oh, am I just sitting there having running nodes going? We solved that problem. The big one, it seems like everyone's excited about, is we handled security like PCI compliance and HIPAA and ISO 27001. If you've ever talked to your CISO, you know all those words. But we do all that too. So it just makes that easier. And our vector database, we know is fast. It's probably one of the fastest ones out there. It is the fastest one. 8 to 23 times. And that based on, let me tell you why there's a little caveat in there, or that range. And this is another, like maybe problem number 6, if we're talking about sixes, is this dimensionality. It's like the larger the amount of dimensions that you create, the slower a vector search can get. And that's one of the things we're trying to solve. It does create a wild swing in performance, but we're solving problems every day. And finally, billions of rows of data. Yeah, we can do that. And a lot of vector databases kind of stop at 1 million or less. So we're fine with tons and tons of data. So it's easy to get started. And I think if you're participating in this workshop, then you are ready to do something. You want to get your hands dirty, get them in there. And I agree, you should. It's really easy to get started with Astra, but you should only go to Astra for a few minutes, and that's to start a database. The rest of your time should be actually writing code. And I put the QR code up there for you to go in there. Super easy. Go to astra.datastax.com. But right away you'll see that there's some examples about these working with RAG, and then vector search with JSON. I mean, I think this is where we should all be right now, playing around with it, seeing how it works, because you're not going to believe it's a thing or understand it until you've taken some data, created a vector embedding, and see what it can do. And I have a couple of workbooks for you to play around with. Well, we have an extensive amount of examples in our documentation, but here, docs.datastax.com, very helpful. But I'm going to pause here for a second. So if you want to, I'll tell you what this one is. This is we did a workshop at a AI engineering summit, and this is the workbook. It's all contained. So if you go to bit.ly/rag4ai, you can, there's a notebook in there that walks you through the process of doing a RAG style application. And you can modify it, play around with it. I mean, there's lots of different things you can do with it. It's pretty cool. But it gives you a very approachable way of starting out. This is your getting started experience. And then at the end of that, you could just say, yeah, I've done a RAG app. Totally. Yeah, I've done that. And I would love to see what you're doing past that. But it's the first thing you should try out, because this is where everything is going to be. The second workshop that I think you should try, the workbook that you should try, is this Clip for AI. Now, Clip is the image processing, and this one is really cool. Text search is great, but Clip is actually the library that ChatGPT uses for its image description stuff. And what Clip does is it takes an image and creates a text description of it. It like describes a picture. But in this notebook, when you walk through it, there's some really cool little things you can do. Like you can do searches, and with some modification, well, not a lot of modification, you can upload your own pictures and play around with it. It is really cool because you can search for pictures with words like, show me a house with pumpkins. And it'll look at the data set and say, oh, here's a picture that has a pumpkin in it. And this one is the fun one to play around with. We were horsing around with it and just having so much fun, just like, because it's cool, it's fun, and you can add your own data and make it really interesting, but it shows you a different mode. And that's really the thing to take away from is this is a different mode of data. This is not text. This is now you're working with images, and we'll add more for audio and X-rays. X-rays is going to be harder, I think. But think about different modes of data, and that's a different variety of how we're working with data in period. That's data is expanding. Our relationship with data is changing. Our relationship with infrastructure is changing. You're probably going to be running a lot of this infrastructure yourself. And so I would recommend thinking about it in terms of that, like the images that you run, the data how you run it, the environments you run it in. Is it going to be in a cloud environment, on-prem? Understand starting with something like this, a workbook. I think that's all I have for now. Yes, that is. Michael, I think if there are any questions, I don't know if there are any that I need to answer, but that's where I'm
Yeah.
at.
Well, I mean, first off, I'll say great presentation. I'll admit I'm still ramping up my knowledge in this space as well too. So it was good to get a lot of the pieces filled in along the way as well too. So
we're all
great
new,
job
right? There's only 5 people in the world who get it, and they probably work at Google. So
Yep.
yeah.
Well, at least you did a good job making it look like you're one of those 5 then. So you did, again, a great job with it.
Thank you.
We've had a couple people dropping in through chat. Most of the questions have been related to just the hackathon and various resources and all that around that, which I've been answering back in chat. However, there was one question, and this came up as towards the end here as well. So I'll just repeat the question, and you may have to ask for additional context. But it says, "Hi, is this LLM agnostic or is it relying on OpenAI APIs in any manner?" And
Love that question. Definitely LLM agnostic, but that opens the door for a different type of discussion. LLMs, yeah, OpenAI made LLMs commoditized, with an easy API, for sure. I mean, you can use GPT 3.5 if you want to go cheap and easy and fast, or you can use GPT 4, but it's an API, right? Running an LLM right now on your local machine, hard, not recommended. It's like you need like a bit mining rig to run it. It's just, it is a really funny part of like our tech. You know, usually when new technology come along, you can run it on your laptop to try it around. That LMs are a technology you can't really do on your laptop well. That is changing though. And, you know, I think the conferences I've been at, the conversations I've seen is that there's two different strains of thought. Strain one is the hyperscalers, like Google's doing Gemini and OpenAI is doing GPT-5, you know, and God only knows who else is going to do what. But it's the mega LLMs, and they want you to buy it as a service. The other side, which is equally as cool and actually much more interesting, is the open source LLMs. And they're shrinking because they're becoming more specialized, and some of them are able to run on your laptop. And there's some really cool, the GPT for All is a great project that it makes it really easy for you to download and run a local LLM. So I know complex answer, this is definitely LLM agnostic, but I would invite everybody to just go out and explore this open LLM space because it's really moving fast and it's really cool. All right, for some reason I cannot hear you.
Whoops. It might help if I hit the unmute button. So
I was hoping it was me.
So we're doing so well with the live stream and everything going well, and I forget something.
So sad. Well, this like everyone knows it's a live stream. Oh, okay.
We are definitely live here. So, but yeah, that's all the questions that we've gotten through chat. I do see a final, and this is probably a good closing message to share. Gabrielle said, I hopped on late, so I don't have any questions at this time, but did just want to thank Docker and DataStax for facilitating this. You were a great presenter and very engaging. So,
well, thank you very much. I hope to see you out there in the meetups and conferences. And yeah, I'll be at the dev.ai conference in December if you want to come meet me in person. So yeah.
Fantastic. And just to wrap up a little bit here as well too. So this webinar has been recorded and it will be available on YouTube afterwards. Again, as a reminder, please go sign up if you haven't yet on DevPost for the AI Machine Learning Hackathon. Additional resources will be continued to be shared through that as well. One of the links there as well is a link to join the Docker Community Slack, where there is a channel specifically for the hackathon. So if you have questions or concerns, or if you need ideas, or if you want teammates, or just bounce ideas off each other, like it's a great place to hang out as well too. So feel free to
work together. Please.
Exactly. So,
yes.
And with that, again, thank you, Patrick. Thanks for the great presentation. It's been a pleasure having you here with us today. And everybody, have a great rest of your Thursday, and we will see you later. Thanks all.
Thanks,